Okay, so now we want to write an equation and determine the acid and its conjugate or base with its conjugate. So let's say we have one equation between, I still choose HF. Okay, so how to determine the acid or base with its conjugate? So let's say we take this. If we can see, for hydrogen fluoride, before the reaction we have hydrogen, and after that the hydrogen is already donated. So because of that, according to the definition, so this is an acid. Okay, acid is a proton donator, and this is a conjugate base. If you have acid, automatically the second one will become the base, and its pairs become a conjugate acid. Okay, and the second one, maybe we can take ammonia as an example. Okay, so before and after, before and after. For the ammonia, so before the reaction we have 3 hydrogen, and after the reaction we gain another 1 hydrogen. So because of that, ammonia was accept the proton. So when it accept the proton, it is considered as a base, and automatically the partner is a conjugate acid, and this is an acid and the partner is Okay, so now how we can differentiate between strong acid or strong base with the weak acid and weak base. So usually we can differentiate based on the equation. Alright, so let's say we want to write an equation for the acid. Okay, let's say we have an acid. For example, chloric acid, which is an aqueous. It will show the properties of the acid when undergoes reaction with water or in the presence of water, and it will produce the hydronium ion and chloride ion. Another example is, let's say we have hydrogen fluoride. It undergoes reaction with water and it will produce if we can see here, there are two different types of equation, this one and this one. This equation represent a fully dissociation. So we can conclude that HCl is a strong acid. And this is a reversible reaction. So we can conclude that it is a weak acid. So this is a weak acid. Okay, not weak acid here. This one is partially dissociate. Both are acid because both produce a hydronium ion. Okay, and usually in our exam or in the purpose of our study, you will be given the Ka value. Let's say for hydrogen fluoride, the Ka is 7.2 10 to the power of -4. The value of Ka can be a hint for you to show that the acid or the acid is a weak acid. Okay, now let's look at another example. Let's say we have a base. Okay, so base, for example, we have sodium hydroxide. This is a very common base. Okay, when it's undergo reaction with water, it will produce another one is ammonia. So this indicate it is a fully dissociate. So it will become a strong base. Okay, so for this one it's produced OH minus. So this is reversible reaction, so they are partially dissociate. Automatically this is a weak base. Both are base because produce OH minus, and usually the Kb value is given to indicate that it is a weak base. Kb represent base, Ka represent acid. So Kb is equal to, for ammonia, the Kb is different, depends on the substance that you use or compound. This is the Kb for the ammonia. Alright, so I hope you will be able to differentiate between what is a strong acid or strong base and weak acid and weak base, and what is the characteristic to differentiate it. Alright, see you in the next video. Thank you very much. So now we are going to discuss how to write the Ka or Kb expression. So Ka and Kb is only for a weak acid or weak base. Alright, so let's see, we have an example of weak acid. So hydrogen fluoride. So this is an example of weak acid. So how to write the Ka expression? Ka represent acid, so it's only involve the aqueous state. Water does not involve because it is in a liquid state. Okay. Next, how to write the Kb expression for base? For example, we have ammonia, which is a weak base. So the expression is Kb So it depends on the concentration of each ion exists in an equation, and Ka and K or Kb only for weak, either acid or base. Right? So that's all. Thank you.